Hi, my friends, we're back with another math outreach lesson. It's been a while since I've made these videos, so hello, how are you doing? I miss you so much. Today we're going to work on multiplying binomials. You might not know what that means yet, but we're going to learn on the next page. The only materials you're going to need are your outreach packet and some sort of writing utensils. There's no need for any calculator for these problems. So I'm really excited for this whole week lesson arc. It's going to be on multiplying polynomials, and we actually haven't learned this in 7th grade before. This is kind of the first time we're doing it, so I'm really excited to see how you all do, because all it does is involve our knowledge of exponent rules and the distributive property, both things that we know. But you might be thinking, what even is a polynomial? Well, I'm glad you asked. Polynomials are expressions that are named by how many terms are in the expression. And so remember, a term is a single number or a variable, or numbers and variable multiplied together. Terms are separated by addition or subtraction signs. So we're going to see examples of what this means in a little bit. And you worked with polynomials this year when you learned how to simplify expressions, when we added and subtracted them, combined like terms. We've worked with polynomials before, we just might not have known their names. And so there are 4 ways to classify an expression. A monomial means there's only one term. So we see here my monomial means 2x. I could also have another variable attached to this and it would still be considered a monomial because there's no addition or subtraction signs. A binomial means there's 2 terms. So I have 2 separate terms separated by an addition or subtraction sign. A trinomial means I have 3 terms separated by addition or subtraction signs. And then a polynomial just means there's 4 or more terms. So there's not 3, so it doesn't make it a trinomial. There's at least 4, but if you have more than 4 terms, it's also considered a polynomial. So thinking about these, we want to identify polynomials just by looking at them. And so I did the first 2 as examples. So we're looking at this first expression. I can see I have 1, 2, 3, 4 terms. So because I have 4 terms separated by addition or subtraction signs, this is going to be a polynomial because there are more than 3 terms. So for number 2, we can see that it's negative 7n to the 7th x squared. So it might be tempting here to say that this is a binomial because you see 2 variables, but the variables are being multiplied together. They're not separated by addition or subtraction, so this is actually a monomial because even though there are 2 variables, it's only one term. The 2 variables are being multiplied together. All right, looking at number 3, I have 1, 2, 3, 4, 5 terms. I immediately know that should be a polynomial, and you can go ahead and explain why this is a polynomial on your own. Pausing the video if you need some time to do that. Number 4 is a little more simple. I have 2 variables. They're being added together. Because there's 2 things being added together, I know this is a binomial. And why do we know this is a binomial? Go ahead, pause the video, explain that in your own words. And finally, number 5. Again, this is 2 terms that kind of have a lot of variables with them. But even though there's more than 2 variables, this is still going to be a binomial because I only have 2 total terms. And so in eBlock challenge, you can go ahead and send me this for a block. What type of polynomial was not included in this example round? What type of polynomial was not included? Just write it down or send me a text with your answer just for some easy blocks. Once you're done with this page, we can go ahead and move on to what we're actually talking about today. So I kind of lied. I forgot. There's one more thing we have to do before we actually learn what we need to do today. We have to refresh the skills I talked about before in order for us to be able to multiply those binomials and polynomials. So, like I said, we need to know a lot about the product rule and distributive property. Those are really the only 2 things you need to know in order to do the lesson this week, all things that I think we're pretty strong at. So, before we get started, let's consider this question. So I have 2 monomial multiplication expressions shown below. I have 3m times 4m right here and 3m times 12p. So using what we know about the product rule, what is the difference between the 2 expressions? So remember, I have the product rule. If I'm multiplying 2 terms of the same base, I can add the exponents together. Are we able to do that for both of these expressions? Use that in your answer. So go ahead, pause this video until you have that answered, then go ahead, unpause, and we can move on to the quick practice round. So like I said, we need to work on the product rule and the distributive property in order to be really successful to multiply these polynomials together. So remember, when we have two terms with the same base, we're multiplying them together, we add the exponents, that's the product rule. And when we use the distributive property, we want to multiply the term outside the parentheses by each term inside. So we're just going to do the first one together of the product rule. So I have 2x squared times 4x cubed, not cubed, to the fourth times y cubed. Ooh, Miss Lewis, it's been a while since I made these videos, clearly. All right, so if I'm looking at these, I see two x's here. So I know I can add those exponents together because the base of the x is the same. So I'm going to go ahead. I can multiply the 2 and the 4 together too because they're both whole numbers. So I have 2 times 4, and they're going to be attached to this x, which I raised to the 4 plus 2. So I need to add the 2 and the 4 together in order to make this new exponent of x. And then the y doesn't have any similar bases, so it's just going to stay the same the entire time. So my final answer here is going to be 8x to the 6 y cubed. All right, go ahead and work on the rest of these questions on your own. Something I'm going to point out in this question here. Remember, when I have a negative outside the parentheses, I'm really just distributing the negative to each term inside. So I'm basically just making every term its opposite value. So if it's positive, it turns negative. If it's negative, it turns positive. All right, let's go ahead and finally talk about our new skill of the week. So today we're going to talk about the double distributive property, which you might be like, what does that even mean? But below are examples of when we would use the double distributive property. I have x minus 2 times x plus 4. I have x squared plus 5x times 2x minus 1, and 5x plus 1 times x to the 5th minus x squared. So based on the examples above, explain when we would use the double distributive property. So like based on these 3 examples, when do you think we're going to use the double distributive property? The criteria for success is really, really helpful here. So determine the type of polynomial that's used in each of those examples, and then use the examples as evidence. If you answer this question fully, you can go ahead and send me that picture for a block. So pausing this until you have an answer written down, and then we'll explain what it is. So we use the double distributive property when we multiply two binomials together. So binomials is the key point here. You can see each of these has 2 terms. We're multiplying expression with 2 terms times expression with 2 terms in each of these examples. And so if this wasn't your response above, you can go ahead and revise like we would in class, and you would cross out words, add new words, and you can send me a picture of your revision for 2 additional blocks. So a lot of block opportunities on this page. But Miss Lewis, like, what do you mean by double distributive property? Like, I know we're going to use it when we multiply 2 binomials together, but it's exactly what it sounds like. We have to just distribute 2 times. So instead of distributing 1 time to each term, we have to distribute twice because there's 2 terms in my front term. And it'll be clear when we go over this next example. So looking at example 1, I know this is filled out on your page. I just wanted to go through step by step so you can understand the thought process behind it. So find the product of x plus 2 and 4x minus 1. So when I'm thinking about this, when I'm doing the double distributive property, what I'm actually going to be doing is taking this x and distributing it to both terms, and this 2 and distributing it to both terms. That's why it's the double distributive property. We're distributing both of these terms to both of the terms in the next binomial. So the first thing I'm going to do is I'm going to show that I am distributing each of these terms to each of those terms, and I'll show you what that looks like. So that means the x is being multiplied by 4x minus 1 because I'm distributing it to both of those terms, and the 2 is also being multiplied by 4x minus 1. So I'm rewriting that in my line 1 so I remember what I need to multiply together, and it's easier kind of to visualize in my mind. The second thing I'm going to do is rewrite to show what's being multiplied together. Essentially now I'm just going to distribute, except I'm not multiplying yet. I'm doing x times 4x plus x minus 1 plus a negative 1. That's really, really important here. I had to catch myself. Make sure we're looking at our positive and negative signs for these. Plus 2 times 4x plus 2 times negative 1. You might think like this is a dumb step, But we're thinking about what all we need to do here, and I have a lot of distribution, a lot of product rule. This is a very important step in order to double check your work and make sure you have the correct exponents. Because like I could go ahead and write this as just like 4x, and then I have to go back and be like, oh, it actually is going to actually be 4x squared because of the product rule. So this is a very important step, so you can go and check your work a little more efficiently instead of having to redo a whole problem. All right. Third line, now I'm going to go ahead and multiply. And I have 4x squared, like we said, plus negative x plus 8x plus negative 2. And this last step doesn't always apply, but in this case it does. I need to combine my like terms of negative x and 8x to get my final response. So then I have my simplified answer, 4x squared plus 7x plus negative 2. So I think the double distributive property is really fun. It can be a little confusing, but I think once you get in the swing of it, it's pretty fun to multiply these binomials together. Let's go ahead and look at example 2. So I want to simplify 5x minus 10 times x squared plus 4. So I'm rewriting like I did for line 1 up here. I have 5x times x plus 4 plus negative 10 this time times x squared plus 4. I have negative 10 because I'm subtracting 10 in this first binomial, so it means negative 10 is being multiplied by my second binomial. Now I'm rewriting it like we did in line 2 up here, and so I have 5x times x squared plus 5x times 4 minus 10 times x squared minus 10 times 4. So now I have 5x cubed plus 20x minus 10x squared minus 40, like we would do in line 3. I finally multiply them all together, and this isn't actually where I'm going to stop. So it might be tempting just to put a box around this because there's nothing else to simplify. The best thing for you to do when you're multiplying these and writing your final answer is to write in what we call ascending order. So ascending order just means I'm writing my exponent from greatest to least. So I'm going to rewrite my answer with my 5x cubed first because that's my biggest exponent, minus 10x because that's my second biggest exponent, plus 20x, which is my third biggest exponent, minus 40. So you're just writing your exponents from the biggest to whatever your whole number would be, or the smallest exponent. That's like the best way to do it. If you leave your answer like this, it's not the end of the world. But if you want to look 8th grade ready, this is what 8th grade expects you to write next year. So if you would see in both of these examples, I followed these same 4 lines of work. And this is the lines of work we are expecting on these packets. So make sure you are following those excellent work steps as we go on to the next page. All right, we're going to do 2 more questions together on practicing multiplying binomials. So you'll see I already wrote the first lines for both of these, and I think I gave you space for substitution. We're going to go through this whole page anyway. So simplifying x squared plus 4 times 2x minus 5. So you see I already wrote my x squared times the second binomial and my 4 times the second binomial. Now I'm going to go ahead and show what I'm going to be multiplying together. So I'm going to multiply x squared times 2x plus x squared minus 5 plus 4 times 2x plus 4 times negative 5. So now I'm going to go ahead and multiply all these things together so I can get my final answer. I have 2x cubed minus 5x squared plus, this is where Miss Lewis made a mistake, it should be 8x. So this is why it's important to write the second step, because I wouldn't have noticed if I just went from this to this that I maybe made a mistake here, because I'm thinking about distributing and I'm thinking about my product rules. I don't know if I'm adding and multiplying sometimes, so you really need to make sure that you have this step here so you can go back and be like, ooh, that doesn't make sense. So it's plus 8x minus 20. This time I didn't have to write it all in ascending order because I already had my greatest to least and just how it fell when I simplified. So I didn't have to rewrite anything here, that's just my final answer. So now, number 2, find the product of 8x plus 9 and negative 2x minus 2. Again, I rewrote the 8x times my second binomial and the 9 times my second binomial. Now I'm going to go ahead and do the simplification step showing what I'm multiplying together. So I have 8x minus 2x, negative 2x, plus 8x times negative 2, plus 9 times negative 2x, plus 9 times negative 2. So now I'm going to go ahead and multiply them together. I get negative 16x squared plus negative 16x plus negative 18x plus negative 18. So I'm not have a final answer just yet. I still have one more step here. I have a line 4. I do have something I can simplify together. So using this work so far, you have 3 lines. go ahead and write the simplified expression below and boxing your final answer. Pausing the video until you're done if you need a little more time to catch up. All right, awesome job, friends. Let's go to the next page. And you still have 2 more questions to do on your own. I realized today kind of was a lot of information. Go ahead and try it on your own using your notes, and you can rewind this video if you need to see another example. If you need more help, you can text me, of course, and you also have the option of joining any office hours. Office hours are fun. They're ways to get blocks for those little block raffles, and you don't waste blocks in the block raffle. So it's like a win-win situation. Like, you don't have to lose your blocks if you win the block raffle. You still have a bunch of blocks. So you should be doing it. And so other block opportunities, I listed a bunch in this video if you need to go back and look, and other ways to earn blocks. You can also fill in the check-in form in the description for blocks, and if you watch this whole video, just send me a picture for the blocks as well. Also, if you subscribe here or to my TikTok, you can also earn blocks, because why not? All right, well, I had so much fun learning with you today. I'm excited to work the rest of this week on the multiplying polynomials and binomials and all that fun stuff. So stay tuned. I will see you soon.